Good evening. I'm very honored to have chance to present this paper in this wonderful conference. And I really like to thank the Olivia for organizing this nice conference and especially inviting me to this event. This is joint work with Donghyun Park. So let me start with motivation of the paper. As everybody probably knows, this aging phenomena is global event, and according to UN projection, by the end of 21st century, fertility rates are projected to fall below replacement levels in all but some small African countries and the Pacific island of nation of Vanuatu. And consequently, population aging and its economic implications will become increasingly relevant everywhere, including developing countries. And this population aging affects every place in the economy. But in this presentation, I just like to focus on the impact on economic growth. And even for economic growth, there are multiple channels through which the population aging affects the economic growth. But the most prominent or direct channel emphasized in the literature is, of course, the decline in the working age population. And that can lead to a slowdown in growth of labor input, and that will eventually lead to a lower growth rate. But recently, a more optimistic view has emerged. As we talked about this whole day today, but longevity is increasing, and old population becomes healthier, and they can stay in the labor market longer and contribute to more labor input, and that is called silver dividend. So in the past, we had demographic dividend, which was the at the beginning of growth stage, especially Korea. We had population growth, and that helped a lot to our rapid growth. But now we are rapidly aging, but still we have some room to add on to labor input, and that we hopefully calls silver dividend. So in this presentation, we investigate the role of the silver dividend in mitigating the adverse impacts of population aging on economic growth. And we'll also empirically analyze the factors that augment the silver dividend and investigate whether it is sufficient to offset the negative impacts of population aging on economic growth. But we have to be careful because, as I said at the beginning, there are multiple channels through which population aging affects growth. So beyond the labor input channel, at least there are three more important channels. And the first channel is saving channel. According to the life cycle hypothesis, old populations tend to desave, thereby reducing aggregate saving. Then, you have lower investment, and that leads to slower capital accumulation. And the second channel is the famous quantity quality substitution emphasized by Gary Becker. I'm not sure you heard about it, but according to his theory, as we have less children, parents are inclined to invest more for each child, so that per capita human capital can increase, which can increase the economic growth. And the third channel is the little bit delicate channel, and we call it productivity growth channel. And there are actually diverse views on this channel. First of all, Johns argues that, I'm not sure whether you agree with this, because he argues that older people are less innovative, so that as the proportion of old population increases, technological progress is slowed down. And there is actually some supporting evidence. But there is some the opposite view, and this guy Habakkuk and Romer and Cutler, they find that actually there is a negative correlation between productivity growth and labor force growth. And Acemoglu and Restrepo actually built very rigorous model that supports these empirical findings. And according to his idea, if you have aging economy, labor shortages drive up labor costs, so that firms have more incentive to develop and adopt automation technology. So you are stick with more labor, then you are stick with labor-intensive technologies, and technological development can be slow. But if you have only fewer labor input, then you have more incentive to develop some other technology that can save labor input, which is automation, or in these days maybe AI can be another possibility. But that technology is tend to grow much faster than the productivity of the whole economy also grows faster, and that leads to faster growth. But unfortunately, when I try to see these different channels and how each channel works for the impact of population aging on economic growth, I found some negative finding, in the sense that actually the major channels through which population aging affects on economic growth is lowered, not faster TFP growth. To our knowledge, Lee and Shin actually include the previous channels and this silver dividend and some more channels. So actually they considered 6 channels altogether, and these 6 channels include physical capital, saving channel, human capital, Gary Becker substitution, quality substitution, and average working hours. That is the kind of labor input channel, and fourth channel is the labor force participation rate. That can be considered as silver dividend, because the old workers can participate longer in the labor market. And fifth channel is the kind of demographic deficit, because that measures shrinkage of labor, and finally total factor productivity. And using data from 35 OECD countries, Lee and Shin find that the most important and the most adverse impact of economic growth is slowdown in TFP. So let me show the briefly. I don't want to go too much in detail, but this is the what I did, and this is the production function, Cope-Douglas production function, and small y is per capita GDP, and that can be represented, multiplication of all those variables, and A is TFP, which is productivity, K capital, H human capital, and so on. So you can believe me that this is the exact representation of the production function. Then you can take the log difference. Then the left-hand side is per capita GDP growth, and on the right-hand side there are 6 terms. Each term represents the channel through which the population aging affects on per capita growth. So for example, this first, I don't know, this pointer is working or not. I don't see it, right?
No, it doesn't work, sorry.
Doesn't work. Yeah. So this first term, that's the capital accumulation channel, and the second term is human capital, and the third one is average working hours channel, and so on. And especially the fourth one, P, represents the labor force participation rate. So that represents the silver dividend. And the fifth channel is the shrinkage of labor population. The data is very standard, so I don't want to go into details, but most data is from the Panwall table, and the country sample includes 166 countries, and the sample period is from 96 to 2019, and I calculated growth rate of 5-year average to construct panel data, and all dependency rate and use dependency ratios from World Bank, and labor force participation rates are from ILO. And this is the main table, and the only table you can pay attention to. And you can see that the first column is the impact of, so, these are explanatory variables, and I have 2 panels. In the first panel, the proxy for aging is old dependency ratio. And the first column shows that in the red circle, that measures the impact of aging on GDP per capita growth. And that's negative. And in the lower panel, I chose the old population share, which is a little bit different from old dependency ratio. And because the old people is divided by whole population to calculate that. And again, the impact of aging is negative. And the trick is that because we have identity here, this equation, if you have the same explanatory variables, then the summation of all those coefficients in the first row is exactly the same as the coefficient in the first column. so that negative impact of minus 0.094 is decomposed into, in this case, 7 channels. And you can see that 6 measures shrinkage in population. So out of about 9.4%, 5.4% is explained by shrinkage in labor force participation. That's the impact of the direct impact of population aging. But fortunately, look at the column 5. That is increase in labor force participation. And that coefficient is positive and almost the same as the coefficient of column 6 in absolute value, which means that this shrinkage of labor force itself is almost offset by increase in labor force participation. I don't have time to, I don't show it in this graph, but the major part of labor force participation rate is coming from older population, and some of them coming from even young male population. But interestingly, female labor force participation does not respond to this old population aging. Okay, and then how come this negative impact of population is taking place? And probably you can see the last, the lower panel, and you can see that. See this and this. The last column is the impact of population aging through TFP, total factor productivity. And that is even higher in absolute value than the coefficient in column 1, which means that more than, this lower total factor productivity explains more than enough of decrease in the GDP per capita due to the population aging. So that's the interpretation of table 1. And but you have to be careful because the this impact is not universal. We find that this impact is highly nonlinear. For example, if you look at the non-OECD countries, look at the first column. They are not statistically significant. So in non-OECD countries, the impact of population aging is not statistically significant. And probably this table is the case when we divide the sample into 2 parts. So in this table, I just used countries with aging variables below the sample mean, which means that these are young countries. Old countries are excluded from the sample. And you can see that, again, the first column shows that, they are positive. The impact of population aging is positive. And in the lower panel, when we use old population share as an indicator of population aging, it is even statistically significant. And in the 8th column, the impact on TFP is also not statistically significant. So why is it so? Why, when we have the non-OECD countries or younger country sample, why is population aging is not statistically significant or even positive. And the reason is coming from this graph. Let me explain what this graph means. So in this graph, the x-axis is old age dependency ratio. Okay, so this is old age dependency ratio. In the second column, x-axis is old age population share. So they are, almost the same thing, indicator of aging. And y-axis is the share of working population share. So in this graph, you can see that in the early stage, when they are very young, and old age dependency ratio increases, actually the working age population share also increases. Because at this stage, mainly youth population share is shrinking. But if your aging indicator increases continuously, and maybe you pass some threshold, like this, maybe 20%, old population dependency ratio is around 20%, then as the economy gets older, working population share is also shrinking. So this means that this aging phenomena, when you stick with this old dependency ratio or old population share, then that kind of bad impact, adverse impact, is concentrated on very old economies. And this is the difference between OECD and non-OECD countries. Again, in OECD countries, this negative impact is more pronounced, but in non-OECD countries, most countries are here, where both old dependency ratio and working age population share is increasing simultaneously. Okay, maybe I'll skip this. So the impact of population aging is highly nonlinear, and we think that this impact of the silver dividend can vary across countries. And we think that there are at least 3 determinants that contributes to higher silver dividend, increase in higher labor force participation. One is life expectancy. As life expectancy increases, individuals, even old workers, are more likely stay in the labor force because they are healthier, and they have to make more money for their after their retirement, because they need to live longer, and they have to work harder, more, to save more. And the second factor is human capital. And human capital is kind of fixed cost you spend. Then once you spend your fixed cost, then you have stronger incentive to participate in the labor market. And there's a model developed by elders that suggests that high human capital raises the opportunity cost of early retirement, making early labor market exit less likely, which makes the old workers stay longer in the labor market. And finally, trade openness And this is a little bit more trickier because on one hand, we expect that countries with higher trade openness may discourage participation in the labor force due to higher competition coming from abroad. But on the other hand, higher trade openness can encourage participation in the labor force because of more opportunities. And there are not many empirical studies, but there's one paper which uses tariffs as an indicator of trade openness, and they find that lower tariff countries lead to higher labor force participation. Yes. So this graph shows that, especially the relationship between life expectancy and annual growth of labor force participation of old people. So y-axis, the increase in labor force participation of old people, and the second paper shows that higher expectancy country, life expectancy country have higher labor force participation, and high on the left hand on the lower panel on the left hand side, higher human capital leads to higher labor force participation, and finally, higher trade openness leads to higher labor force participation. And this is a little bit, I have to do more on this. So this is a little bit tentative results, but because we have very non-linear results, so and this is the pension fund conference. So I decided to do something on related to pension fund, and this case, I tried to divide the sample based on the size of the government. So I measured the size of the government in two variables. The first panel is government consumption, and the second panel is tax. And surprisingly, this is the impact of aging on per capita GDP in high consumption, government consumption countries. And that is not negative, and that's not statistically significant. And you can see that this labor force participation, which is silver dividend, and that is the greatest in high government consumption countries. When I use tax as the measure of government, I have similar results for silver dividend, but the first column is negative. So that in those countries, still we have negative impact of aging on per capita GDP. Okay, so let me conclude. There are growing concerns about the negative impact of population aging on economic growth, and we find that the primary channel through which population aging harms economic growth is lowered TFP growth. And we find that there is a substantial silver dividend in the sense that almost offsets the decrease in labor input due to population aging. And there are some factors that increase that mitigating impact of silver dividend, and those three factors are higher life expectancy, human capital, and trade openness. This higher life expectancy, of course, includes the healthy old workers. However, this silver dividend and the broad increase in the labor force participation is not enough to completely offset the negative impact of aging on growth, because the most important factor that drives the decline in per capita GDP is the lowered total factor productivity growth. And our analysis also indicates that this population aging has a heterogeneous effect, in the sense that various countries can have various degrees of impact of population aging on growth. So very quickly, I just read my policy implications. First, prioritize total factor productivity, because that's the most important factor. And the second, help old individuals maintain good health. And third, encourage lifelong learning and reskilling, which is related to human capital. And leverage trade openness. I'm not sure this is easy to do under these circumstances, but that's the one implication of our study. And fifth one is optimize government size and tax structure. And I don't think that just increasing government size is doing most of good things, but you have to be design carefully how you spend your government consumption to increase the encourage old people have a better environment or better health conditions that can contribute to higher silver dividend, and support age-friendly work environment. Maybe one important thing is the fostering intergenerational collaboration in the work site. And finally, strengthen healthcare and pension system that gives the better health in old people and financially in better condition to continue their career. Okay, let me stop here. Thank you.